So hopefully everybody watched the live stream on Wednesday. We did just one live stream and did the same demonstration in both, where we introduced the idea of inheritance, where you can take a class and then you can subclass it, and it inherits all the behavior and the state of its superclass. Sometimes they're called the parent-child class. A classic example is going to be animal, cat, and dog, right? Where all dogs are animals, all cats are animals, but not all cats are dogs. And in fact, no cat is a dog, right? And we did an actual demonstration with a person, author, director, and we realized very quickly that, wait a second, there are some people who are authors and directors. And if you don't have that strict is a relationship, then you probably don't want to lock yourself into that hierarchy. And so as an alternative, what you can do is you can use composition over inheritance. Now, the entire time I was demonstrating, let's see, author, director, and person. There it is again, right? And this is called a plant UML this is a UML diagram generated with plant UML. And I've gone ahead and put the instructions, a link to the instructions here. It's just on the GitHub page there. You can install plant UML. If you're on a Mac, you also have to install something else first. But otherwise, it's a free plugin, and all you have to do is select things over here, and it automatically diagrams them for you. Right? We do not want to see a big giant God diagram like that, though. So make sure that you are splitting your diagrams up when you actually do this. Now, we're not expecting a diagram on your design document today. That would mean that you already implemented everything. That means you're a week ahead if you did that. Great job, right? But all we're doing is expecting you to do it on a whiteboard. Take a picture of it. Do it on a piece of paper. Take a picture of it and put that into your document. We want to see what classes you're doing, what the member variables of that class are. For example, here is what the book looks like, right? There's all the member variables, their types, and they're all private, and then we've got a bunch of getters and setters. In fact, you don't have to write out all the getters either. You can just say getters or whatever. Yeah.
I feel, this might just be me, but I feel like when trying to approach the assignment, I feel like I'm doing too much at once.
Probably. Yeah.
I'm doing, implementation and not enough planning. So like, how do I know when too much is too much?
So if you're following our Gantt chart, you would not have started implementation until Monday. And I'm not going to bring up the Gantt chart, but the idea is that also at the beginning of the sprints, remember these are called sprints every 2 weeks or so now, you should be planning up front, right? What am I going to do? And then commit to doing it that way. That way you're not jumping ahead, and you've planned out step 1, step 2, step 3, like we did in the Gantt chart, and then don't jump to step 3 if you haven't done step 1 yet. But it's not a bad idea to go back and forth, because it's like the Escher, MC Escher picture of a hand drawing a hand. It's a continual feedback loop process where you design it one way, you start implementing it, and you go, oh crap, no, that's not going to work. You go back, you redesign it, now that's going to work. That's a little bit better. And then your implementation informs your design, and back and forth, right? So yeah, I mean, it's unavoidable to redesign something, refactor something, right? But following a Gantt chart is a good idea, right? Or your own Gantt chart, or your own plan for each sprint. Anyway, back to this, where we decided that the director author is probably not an appropriate inheritance, because we have Stephen King, who is both of those things. And I'm sure that there are many other people that have written books and directed films, right? Probably Jim Jarmusch? I'm not sure. Anyway, so to continue, oops, I'm on the wrong page. There we go. All right, so to continue, our observations were that were as follows. And then we've got 3 types of relationships that we hinted at last time. And for that, I've pulled out another diagram here. Now, we're not using dogs, cats, and animals here, but we're using something very, very similar, right? You have a bird, which is a generic idea of a bird. And then you have a robin and an ostrich. A robin is a bird, right? It follows that is a relationship. That is fixed. There's never a time when a robin is going to be something else. An ostrich is a bird, right? But they do things differently. How does a robin move? It flies, right? Or hops on the ground. Do ostriches fly? Nope. Also, ostriches are delicious, and robins are not, right? You can get yourself an ostrich burger at Fuddruckers, right? Do we have any Fuddruckers anymore? That might be gone. You could get a whole bunch of different types of meat there. Anyway, if you treat a robin as a bird, it's called covariance, or covariant type, or covariant relationship. And that's always going to be safe, because it follows that is a relationship. You can always take a subclass and treat it as a superclass. Yep, we're good. And a dog is always an animal. That's always going to be safe. But can you necessarily take a bird and force it to become a subtype, an ostrich? If you started with an ostrich, treated it as a bird, well, yeah, you can force it to become an ostrich again. But what if you started with a robin and you force it to become a bird, and now you're forcing it to become an ostrich? That doesn't work, right? That bird don't fly, right? If you want to say that. I didn't want to say that, but that's contravariance, right? Contravariant relationships, right? Sometimes it's safe. Sometimes you have to check, and we'll talk about that in a second here. But otherwise, the third one is an invariance. You can never take a sibling class and treat it as one of its siblings. You can never take a robin and force it to become an ostrich and vice versa. That would be an invariance, okay? So that's never safe, okay? So how do you know the difference? Sometimes it's okay to check before you try something. Over here with our demonstration from the other day, where is it? Demo right here, right? So I think I've already got the code here. Remember that we had David, who is a director, but when we created David, what we did is we called the director constructor, but we treated him as the super type person, right? And then when we wanted to create a film called Eraserhead, we had to force David here to become a director because this film constructor only takes directors, not generic people, right? A safer way of doing that would have been an if-else-if statement here, using the instance of keyword. If David is an instance of director, then this typecast right here is safe, right? You're checking the contravariance. Otherwise, David is not a director and it's not safe. Right? The only time that you ever do this is if you've got a constructor, right? You can use the instance of keyword to determine if the typecast is appropriate, but you almost never want to do this. I'm only showing it to you because eventually you'll have to use it. If you use this often enough or to determine the control flow of your program, it's a bad design. If I use this, for example, to say, if they're a director, then pay them $10,000, right? Else if, and then we'll add another one here, else if David is an instance of author, then we'll go ahead and pay them $20,000. Authors are better than directors. Pay them $20,000, right? And you'll see this in next week in your lab when you're determining pay structures for employees, right? If you find yourself doing this instance of, it's wrong, right? First of all, you're breaking encapsulation. Where should the data be to determine how much they're being paid? That sounds like a director thing. It belongs in the director class. Sounds like an author thing. It belongs in the author class. Not only that, but what happens when you have a new type of person, a painter, right? What do you have to do? You have to come in here and add another else if statement, add another else if statement, add another else if statement. And that is a huge red flag that you have designed something wrong, right? There is only one instance in which you should actually be using this, right? And that instance is where you have to use it, right? The only time that you have to use instance of is to do a contravariance, when you're making copies. I've got this thing. I need to know what type of thing this is because I need to call a specific constructor. I need to call the director constructor because this is a director. I need to call the author constructor because this is an author. That is the only time that it is allowable to do something like that. Okay? And that's because we don't have contravariant constructors. I don't know of any language that has a contravariant constructor. They have contravariant patterns like a factory pattern and stuff like that, but it's something that's not supported in any programming language that I know of because it'd be very, very difficult, right? All right. So motivations for inheritance. It provides a way to utilize code reuse. You don't have to locate code in a superclass and a subclass. You just put it in the superclass, and it is inherited by the subclass. It is a way for you to reduce redundancy. It is a way to provide a way to organize your code into a hierarchy. Right? You do this all the time. The last section didn't remember it, but what's the mnemonic device for like phylum, kingdom, genus, species? King Philip enjoys something. No. All right, we're looking this up. We've got enough time. What is it? Mnemonic device for kingdom, phylum, species, domain. That's it. What is a good mnemonic device? Hopefully this is safe. Dumb kids prefer candy over fancy green salad. There, where was it? King Philip. King Philip came over from Great Spain. There we go. All right. So it's kingdom, phylum, class. There we go. Order, family, genus, and species. Right. Now, why do we do this in biology? It's because we have millions or billions of different organisms on this planet. How do we organize them into something that makes sense? Well, it makes sense to put all plants over here, and all mammals over here, and all reptiles over here. Well, a reptile and a mammal are kind of similar, they're dissimilar to a plant. And so you come up with this hierarchy of organization, right? And that's exactly what you want to do in code. You want to organize your code so that it makes sense, okay? It is if it is well designed, it is well designed if the introduction of a new class does not break any other code. This is not well designed, right? Because the introduction of a new class, say painter, would now break this code over here. Instead, all persons should have get pay rate or something like that, right? And then you override that in these subclasses to provide $10,000, $20,000, or whatever, okay? All right, so well designed means that you're not breaking anything if you introduce a new thing into the mix. All right, with the rest of our time today, we're going to do another demonstration. All right, so we're going to design classes to support assets, right? A stock and an annuity. All right, so just as a quick financial lesson here, a stock is basically a claim into a country, it's a share of a company, right? So stocks have shares and share price, right? So Google, right? Google would have, I don't know what their market cap is, billions of dollars, but one share would be equal to 180 bucks or something, right? And so if you own 10 of those, you'd have $1,800 worth of Google, right? You can own fractional shares, so you can have 1.5 shares, right? An annuity is a terrible financial investment, but what you can do is you can purchase an annuity at a price lower than its value, and then over the years, it will pay you a fixed monthly amount. So for example, I could pay $50,000 now, and then over the next 5 years, you would pay me $100,000 a month. 5 years, monthly payments would be 60 payments times 1,000, that's $60,000. That sounds like a $10,000 profit over 5 years. Wow, that's great. You can do better with stocks, right? An annuity has a monthly payment and number of years, right? We'll just say that you can only purchase it for full years, like 1 year, 2 years, 3 years, or whatever, okay? Just to keep it simple. All right, I'm going to start over here in a new package because eventually I want to use Plant UML here to understand my design, all right? I'm going to go ahead and create a new class for stocks. All right. And by the way, it's not the stocks class, it is the stock class, and you own a bunch of instances of stocks, right? We never pluralize class names, okay? All right, so what belongs in a stock? Hopefully, two things that I just said, the number of shares and the share price, right? So public or private, double share price, and private double num shares. Okay. What else? Okay, name, private string, name. That could be the ticker name, Goog, right? Goog for Google, or APPL is Apple, I think.
Yeah.
All right. You could have the ticker price, or you could have the full name of the company, right? What else? Is there a difference between me owning these shares and you owning these shares? If there's not, then I'll take all your shares, right? So let's go ahead and add a person who is an owner, right? And we do need to bring that in because now it's in a different package, right? And this is kind of like an account or an asset. We need some sort of identifier. And so I'll say that this is a string ID for now, right? Okay. Now in your project, of course, this will be a UUID, right? And by the way, there is a built-in UUID class. I think it's in Java Utils. Yep, it is. Right. There you go. So you can always be assured that it's a valid UUID if you use this class. Right. I like that. Let's just go ahead and leave that. Right. Okay. All right. That's good enough for now. Let's come over here and let's do annuity. Annuity. There we go. All right. What's an annuity going to have? Hopefully those two things I said, monthly payment and number of years. So private double monthly payment and private int num years, because we said that we're only going to allow full years. Okay. What else? A what? An owner and an ID probably. Right. So let me come over here. Uh-oh. What principle did I just violate by copy paste-ing? The DRY principle? Don't repeat yourself. I've got repeated data here, and I've got repeated data here. And I showed some tricks to the last, yeah, you can look at it side by side, or let me move it over here. There we go. You can look at it side by side for comparison. Here's another trick. Let me reopen that. If you want to, you can go ahead and select multiple files and then compare with each other. There we go. And then you have basically a get diff side by side. If I've shown that before, sorry, just a review. But also somebody was asking because they lost a bunch of history, right? I think I've showed this before, but just a reminder, you can always compare it with your local history here, right? There we go. Sometimes they'll be missing, but other times they'll have a complete history. Looks like every time you save, it looks like, right? I think you can clear the history, but why would you? It'll take care of it itself, right? But you can. Oh, it looks like it was empty at one point, and there's my example there, right? That's just a couple seconds ago. But otherwise, everybody's going to learn the hard lesson at some point, right? That you're going to lose something, and you're going to say, "Darn it! I wish I had saved it on get," right? And unfortunately, it's just a fact of life that you have to lose something of value before you start valuing the tools that would have saved it. Or you can listen to me and just start using Git and GitHub. Right? Otherwise, most people just need to learn that lesson the hard way, unfortunately. So start using Git. And by the way, if you need a lesson on how to do it in Eclipse, watch video 0.2. I walk you through the creation process, the commit process, the pull process, all of that. All right, so redundancy. Let's use inheritance to get rid of that redundancy. What would you call these two things? A stock and an annuity. Asset? Okay, so let's call it an asset. Right? As a superclass here. And I'm going to promote the common features, the UUID and the person, the owner, and I'm going to promote them up to the superclass, right? And getting rid of them in the subclasses here. Right? And to put them into an inheritance hierarchy, I'll put extends asset, right, in both of these classes. And now they have inherited all of these things. Let me show you on Plant UML. Right? There's a UUID and an owner up here, and then a monthly payment, num years, and the rest of the stock stuff over here. Right? Stock stuff is in the stock class. Annuity stuff is in the annuity class. But common features are in their superclass. Okay? So I have solved the redundancy problem. Let's continue. Over here, what else do you need? You need a way to construct it. Create, retrieve, update, and destroy. Right? All the stock stuff. When I do this, all right? Okay. If I start at the subclasses, I have a problem. What is the annuities account number and who owns it? We don't have that information. Always start at the top. Let's put a constructor up here. Right? So, constructor using fields. There we go. Now, the superclass has a constructor that accepts the ID, the account number or whatever, and the owner. Down here in the annuity class, it is broken are the constructor that was auto-generated here. So let's go ahead and get rid of it and redo that. Constructor using fields, monthly payment and number of years, but guess what? Now, because the super constructor has UUID and owner, it does it for me right here. All right. You don't have to type that much, okay? All right, and I've cleaned everything up, good. Let's do the same thing over here in the stock class. Source, generate constructor using fields, and it'll do the same thing over here, okay? This is a trivial function. You do not need to document it, but you do need to document your classes. Document. Right. It's just a stock. I mean, it'll take me the same amount of time to do this. So represents a stock asset. There we go. That's all you really need. Right? Author headers do not belong on every single class, just the main class. Or since you're doing a project, we have a README file now, and you just put your names in there. Right? Annuity asset. Okay. That's spelled correctly, isn't it? I don't know why it doesn't like it, but whatever. Okay, so now I've got enough to get started to build some stuff. There's me. I'm going to own all this stuff. So let's create some stock. Google. Right? New stock in Google. Right? Oh wait, it's the account number is 1234. I'm the owner. There's the name. Let's say that I own 100 shares of Google, and I think it was $184 or something, and some cent and some change. Is that right? Oh, share price, then number of shares. So share price goes before number of shares. Right? And why are you still complaining? UUID. Oh, it's a UUID. Maybe I don't want to use UUID now. Right? UUID dot random. There we go. Perfect. Right. Give me another stock. What stock do you like? SPY? Well, SPY was what? All right. It really didn't like that because, okay, there we go. SPY is, that's just the S&P 500, isn't it? Yeah. Okay. Let's be more specific. Oh, I remember. App Harvest. I own like 10 shares of App Harvest. I still own 10 shares of App Harvest, APPH. Right? And they are worth a whopping 1/10 of a cent now. Don't buy SPY. Buy into total market funds like say VTI or VOO. Right? VOO is just the S&P 500, but for Vanguard. What's SPY? Who does that?
I don't know. I think it's just the main one.
Okay. Well, Vanguard is better. They're a better investment company, and VTI is yeah. Like, who the hell are they? But Vanguard is very reputable. Hey, great, we're up to 301.83 now. Right? But Vanguard is total market index plus international funds. Right? Only invest in ETFs. Don't invest in regular stocks because eventually that happens. Right? So let's go with the App Harvest, and we've learned our lesson, APPH, and they are worth a whopping 0.001, and I think I own 10 shares of them, right? At their height, right? Okay, so there's some stocks. Annuity, right? A1, because they don't have names, new annuity. Right? And once again, I'm going to go ahead and generate a random UUID, right? And it doesn't have a name, it just has number of months, so number of years, then months. What was it called? What was the order? Looks like monthly payment and then years. So my monthly payment is, say, $1,000. Right? That's the example that I gave for 5 years. Right? And let's do another annuity. I misspelled it again. There. A2, but it's much smaller, say $100.50. Actually, let's keep the math nice and neat. There we go. $100 a month for 3 years, that's $3,600. That's the value. Right? All right, what am I worth? All right. What is my grand total? Grand total. Grand total value. Google dot. Oh, how do I calculate this? Right. So one way to calculate this is to go over to the stock and start generating those other things. What else do we need? Getters, not setters. Two-string method if we want that. A hash code and equals, right? Et cetera, et cetera. Let's go ahead and at least do the getters. Right? Done. All right. Now over here, I can say google.get numshares times google.get share price, right? And then I can say grand total. Oh, here, I should have started it out at 0, sorry. 0, and then grand total plus equals that plus equals app harvest. So 10 shares, I own a penny. That's why they call them penny stocks, right? They are not a good investment. But is that the appropriate object-oriented way of determining this? Like the isotope class, I've ripped it open, pulled out its guts, the share price and the number of shares, and I've done the math outside the class. Don't do this. This breaks encapsulation. So I'm going to go ahead and get rid of those things. Where does this operation of multiplying these two things together belong? Just repeat to yourself. It's a stock thing, therefore it belongs in the stock class. Right? X things belong in the X class. Public, double, get value. Right? Do I have to pass anything into here? The stock and the number of shares? That's part of the object. Right? So return this dot share price times this dot num shares. Right? That really cleans things up over here. Right? Now my grand total is going to look something like this, or my calculations are going to look something like this. Google.get value. Right? Grand total plus equals app harvest dot get value. Right? Grand total. There we go. Right. You didn't have to rip its guts out now. It's taken care of inside the class. Good encapsulation. Right? So this is good, or at least better, encapsulation. Okay? Likewise, what about an annuity here? I'm not even going to bother writing any code here. I'm immediately going to jump over here and say that we need, this is asset, that we need another function here to determine its value. Public double get annuity value. Does that sound like a good method name? We'll leave it for now. Return monthly payment, or this dot monthly payment. How many months in a year? Times 12. Right. Times this dot num years. Right. Now, by renaming it get annuity value versus the stock over here, I am forced to use different names. Right? A1 dot, instead of get value, I have to say get annuity value. Right? And A2 get annuity value. Right? But they're both what? Assets. Remember? Let me highlight everything here. These are both assets. There's a get annuity value over here, get value over here. I don't want to have to maintain two different collections, one for annuities and one for stocks. Because what happens when you introduce another class? Now you have to have another collection if I want to store all these things into one collection. Right? So let's go up to the annuity class here. Right? And let's define, not the annuity class, the asset class. I'm going to use the same name here. And I'm going to promote this up to the asset class here. Right? Except that, what do I return for this? Just to get it to compile, I'll return 0 for now. Not ideal, right? 0? Okay. Let me come over here to the annuity and or to the demo class, excuse me. And let's go ahead and rename this to get value. Right? And then you can print out the grand total. System.out.println grand total. Right. Now, hopefully, this is giving you some bad vibes. 4 lines. What should you do instead? And this is just CS1 stuff. For a loop, exactly. So let's come up here and create a list of assets. All right, why did you immediately jump to assets? This is not going to be a list of stocks and then a separate list for annuities. it's going to be a list of all the assets. My stuff, right, is equal to new array list of assets. If I had put stock in here, I could of course add my stuff dot add Google, and I could add app harvest after I've created them. Come on. But would I be able to add these two annuities? My stuff dot add A1 and add A2. Oops. A1 and A2. Is that going to work? Because this is a list of stocks. So let's treat it as the superclass asset. And now you can add stocks and you can add annuities. And if you introduce a brand new class, checking account, you can add that too, right? Cool. You don't break any code. All right, so there's a better encapsulation. Let's go ahead and go into a for loop for asset A in the class, or in the collection, my stuff, right? What'll it look like? We can get rid of all that, and it'll be A dot get value, right? Grand total. What am I worth? 82,000, awesome. Right. All right. So let's come back over here to answer this question now. 0. That's not very satisfying. Can you even really begin to answer this question? This is a generic asset class. All you have is an ID and a person, the person who owns it. You can't even begin to answer this question. 0 is wrong. Because what if you own my app harvest? It's essentially 0, right? What if it gets delisted? Then it is definitely 0, right? And so how do we determine that this is an actual asset, it's just not worth anything, versus this is a generic asset, I don't know what it's worth? Right? One way that you could do that is to make this a big D double and return null. What happens over here in the demo class then? If I have that and I try to add it up, a null pointer exception gets thrown, right? Okay, well, if we're going to throw exceptions, we might as well throw one. Throw a new runtime exception. I don't know. Right? I don't know what the value of this thing is. Right? These three solutions, none of them are satisfying. Right? If you don't know, the best way is to say that you don't know in the code. I don't know what the body of this function should be. So I'm not going to give a body to that function. It's not compiling because what we need is what's called an abstract class. Let's take a look at this diagram right here. Okay. You've seen this before, right? You've seen tree sets, you've seen array lists, and you've seen sets and lists and collections here, right? It's actually a lot more complicated than just that. Down here, what we have are concrete classes. We don't call them concrete classes, but we have classes that you can actually instantiate. You can create an array list. You can create a hash set, right? Up here, above that, we have what are called abstract classes, right? So the quintessential example that we give is there such a thing as a perfect circle, the quintessential circle? Abstractly, yes. Mathematics can describe the perfect circle. That's what pi is, right? Pi is the circumference of a circle with radius of 1 unit, right? Can you draw it up on the board? Nope, because whatever you draw will be imperfect. Can a computer draw it? Well, the computer will be a little bit better, but it'll still be a collection of pixels, not a circle, right? There is no such thing as a perfect circle in nature. Right? In mathematics, there is. We call those the Platonic ideals, right? If you've ever done Plato or anything like that, right? That we've got these ideas of abstract ideas. There's an abstract idea of a chair, right? There's the perfect chair, but the perfect chair doesn't exist because once you create a chair, it's no longer, it's a concrete example, not an abstract idea, right? And then above that, we also have pure abstractions, okay? And we'll talk about that later, but what I want to do is treat this as an abstract class and look at the consequences, right? So, abstract. The abstract keyword can be placed between the public and the class to make this an abstract class. Now what you can do is you can make this into an abstract method. Right? I don't know what the implementation should be. If I knew what the implementation would be, I'd give it a body, and it would have an implementation. Here, though, I have no idea, so I'm not even going to bother to try. It's an abstraction. The stock class that overrides that method and the annuity class that overrides that method, that's down here in concrete land, right? This is an abstraction up here. Right? As a consequence, over here in the demo class, before I could have done something like this. Asset A is equal to new asset, and uuid.random, and then me as the owner there, right? Let's go ahead and take away that abstractness and show you that I could have done that, right? And let's get rid of that for a second, right? Now the asset class exists, right? And I can create an asset. But if I tried to put, I could even put it in my list, right? Watch. I can, let me bring this up here to the top, and then my stuff.add A, right? Okay? And it is an asset, but it doesn't have this get value function anymore. Let's go ahead and give it a get value function. But I am forced to give it one of those three things: null, 0, or whatever. Right? Okay, and it's not abstract anymore. Right? But should I even be allowed to create an asset? Right? Should you be allowed to create a bird? Right? I mean, you can hatch a robin, you can hatch an ostrich, right? But can you hatch a bird? It's too much of an abstraction. It doesn't make any sense. So what we'll do is we'll restore that abstraction, get rid of our implementation, make it into an abstract class, right? And now over here in the demo class, everything else is perfectly fine now, except this one line. You are not allowed to create an abstract class, right? So you cannot instantiate an abstract class. Right? That actually solves a lot of our problems. If I make something abstract, I'm saying you cannot do that. Right? Just like you cannot create an abstract collection or an abstract list. You have to create an array list or a linked list. Right? You cannot create just a generic collection, because how does it hold stuff? Oh, it holds it using a hash table. Okay, then you're shopping below. Right? That's where you want to be. Right? Okay? All right, and then I can't add it anymore because it doesn't exist. So I'll get rid of that as well. Right? Okay. Now let's take a look at our new taxonomy here, basically. Right? Now, unfortunately, PlantUML has a bug that it doesn't actually say that this is a abstract. It should have an A there instead of a C. C stands for class, like a concrete class. A should be here for an abstraction. But you do know that it's abstract because if I zoom in on this, you can see that get value is italicized. And then down here, get value is not italicized, meaning it's overwritten to provide specific behavior. Okay? All right. Questions on that so far? Let's take it a step further. I don't need this anymore. All right. Let's take it a step further and go one step up. Right? Now, over here in my abstract class of an asset, it has state. It even has behavior. Right now it has, I could put in getters and setters. We should do that. Put in a getters at least. Never setters because prefer immutable objects, right? But it has state and behavior. Half of it, or some part of it, is abstract, but other parts of it are concrete, non-abstract. Right? We don't say concrete, we just say non-abstract. I don't know why. Right? That's the antonym. We should use it, but I'll use them interchangeably. Right? But don't use them in front of other people because they'll always say, "What the hell are you talking about?" Right? But understand that some of these things are non-abstract and some of these things are abstract. What we have above is a pure abstraction, an interface. Okay, let's look one of these things up. Let's look up sorted set. I do need my browser. Java sorted set. Okay. Now, if you were to look at this, all it does is provides abstract methods. Right? All of these things are abstract because it's a pure abstraction. There is no, it looks like it's inherited some methods from above, from set or something, but it is a pure abstraction. Okay? In fact, if we looked at it, let's do that. Sorted set. The actual code, I mean, right? Foo. And then we'll need to bring it in. Come on. Import that. Let's just jump in there. Right? It's an interface. That's abstract. And by the way, there's no abstract keyword here because it's an interface. Everything in the interface is going to be abstract. So you don't need to put the keyword. Is there a function body there? Nope. Is there a function body there? Nope. 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 No function. Okay. Ignore that for a second. That's a mistake that they added in Java 7 or so. In fact, all of these are mistakes. All these are mistakes. Ignore all of those. Right? I'll talk about those later. Right? But anyway, it's supposed to be a pure abstraction. Okay. And it should have, and it was at some point here. Other things like random access. Let's look that up over here. So random access, Java. There we go. This is a pure abstraction. Do you see any methods here at all? Nope. This is an aspect, right? And what thing has this aspect? An array list, because it is represented by an array. And an array has random access. Do we remember what that is? If you have an array and you want to get to the fifth element, how do you get there? Right? Well, each of these are an integer. That takes 4 bytes, 4 bytes, 4 bytes, 4 bytes, 4 bytes. Right? And at the beginning, minus those 4 bytes. So 4 bytes away from the beginning address, right, times 4, I only have to jump 16 bytes away. Right? That's randomized access. Now, think about if it's the millionth element. Right? Do you have to go along and do a million calculations? No. You just say 1 million times 4, that's 4 million. 4 million bytes away from this memory address, I can jump there. Right? That's what random access is. You do not have that with a linked list that we'll talk about later. Right? A linked list has a node, and then you can go to another node, and that you can go to another node, but you can't jump to another node. Right? It does not have random access. So this is an aspect that is being given to these things. Also, note here, what else do you see? Down here, you can only ever inherit from one class. You only ever have one parent, right? But up here, clonable, let's look at tree set over here. It's got 4 different things that it's inheriting from interfaces here, right? These are sometimes called mix-ins. If you go to an ice cream store, what can you get? You can get some peanut butter cups, right? You mix it in. I want also Reese's Pieces, right? I'm going to mix those in. I also want some peanut butter. Mix that in, right? Right? Those are mix-ins. You can add stuff and mix it in as you want. You can only ever mix in one class, but you can mix in as many interfaces as you want here, right? So what would that look like over here? Assets have owners. So let's make them ownable. Implements ownable. Now, what does it mean to be ownable? That's where we define the interface. Let me go ahead and let's collapse this. That's too much there. There we go. Ownable. There's a public interface ownable. Now, like random access, I don't have to define anything into it. I could just say that it has a property, that it is ownable. But I am going to add something. Public person get owner. Right? There. And I need to bring this in. But otherwise, I'm saying that if something is ownable, it always has this method that you can get the owner. And that method always returns a person. And it's always public. Right? So over here in the asset class, we're already fulfilling that because I've got this right here. If I didn't have that, by the way, then it would be an error. Oh, I guess the lower ones would be an error. It says that you need a get owner method here, right? Right? Yeah, you need a get owner method here. You need a get owner method here. But since it's up here, I'll restore it, and now it inherits those two things, and now those two annuities and stocks are now happy about it. Once again, let's take a look at the diagram, right? And increase that. Now it's looking kind of like this worldview over here, where I've got multiple layers. I've got concrete classes down here, an abstract class in between, and then a pure abstraction up here. And the reason that you would want to do this is because you would maybe want to inherit from multiple things. Here's a perfect use case for it. Right? A use case, not maybe a perfect use case. Say that we have a bunch of employees. We've got hourly employees and salaried employees. Salaried employees are paid an annual salary, and then they're paid, like faculty are paid 9/12, meaning that we get paid for 9 months, but they spread it out over 12 months so that we don't get paid nothing during the summer, right? Versus an hourly employee. They work so many hours a week. All of our LAs are hourly employees. And they work, 10 hours a week. They get $15 an hour. That's $150 for that week, right? So their pay is different, but they're all still employees, right? And so they're payable, right? We have to pay our employees, right? But we also pay suppliers if we're a business, right? So employees and suppliers can both be payable. But are suppliers employees? Are employees suppliers? No. So we didn't have to lock them into that hierarchy, right? Now, an employee is a person. We're going to treat them as persons. But also, we all have this other classification over here called interns, right? Never accept an unpaid internship in computing, right? But there are plenty of disciplines where there are unpaid internships, right? For experience or whatever. And so they're not payable in this case, but they're still people, right? That allows an employee to inherit from multiple things, right? It allows us to mix this personhood into other things everything that's a person. But it doesn't lock us into a hierarchy because a person might be payable, but a supplier is also payable, but they're not a person, right? So it gives you the flexibility to do something like this. I would actually argue that this should be an abstract class because an employee, okay, how do they get paid? I don't know. An hourly employee gets paid a certain way. A salaried employee gets paid a certain way. But the abstract idea of an employee, I don't know how they get paid, right? So we've got concrete classes here down at the bottom. We've got abstract classes in the middle, and then pure abstractions, interfaces up here. What else might we want to, and this is going too far, but I can show you that you can implement multiple interfaces. Comparable. That's not going too far. Comparable to an asset. There we go. Excellent idea. Let's do that. What would I need to do now? Let's go ahead and say public int compare to asset that, right? This and that. So if we'll just go this dot uuid dot compare to that dot uuid. There. I'll just do UUIDs. They're the same asset if they have the same unique identifier, right? And then return. Sorry. There. And did I have to do that in the stock class? Did I have to do that in the annuity class? Nope. They inherit everything automatically. Let's take another look at what it now looks like. There. I'm inheriting from two interfaces, right? You don't actually inherit anything. You just say, this should have this method, get owner. It should be comparable. Comparable, and now look, it is correct here. It's an I for interface. This should be an A for abstract, but it's not. It's just a bug. Don't worry about it when you generate your own. This is the best that we could do. There was a much better version of Plant UML. I forget what it was called, but the maintainer was killed like 10 years ago in a car accident, so it's dead code now. Yeah.
Why does the comparable thing go into asset and not comparable.java?
Oh, comparable.java. What do you mean?
You had it inherit as an interface.
Good question. It's not smart enough to figure out that it's in. What do you mean?
The compare to function.
Right.
Is it in the interface comparable, or does it go?
Yes, it's in the comparable interface. Let's go ahead and take a look at it.
Oh.
Here's an interface called comparable that's built into Java.
Oh, so we didn't have to make our own.
No.
Okay.
This is built into Java, and all it defines is compare to. That's it.
That's a lot of words. Compare to.
Well, it's telling you what the behavior should be, right? So when you're doing this, always make sure that it's a total order. This is a lot of words to say it should be a total order to people who don't know what a total order is. You will know what a total order is because you're taking 235. Right? A total order is a binary relation that is transitive, antisymmetric, and reflexive. Right? You'll get to that eventually, right? Hopefully. Right? There we go. But that's what that's saying. Right? And by the way, in case you think that that's busy work or whatever, no, it is not. We're done. So I'll just impart this last story here of when I worked in industry. I knew that it should be a total order, and so we were organizing all of these, not sales, but all of these shipments because I worked at Warner Enterprises, and all of these shipments, and I put it into something with a total order. I mean, I knew that it had to be a total order because if it was the same weight, same destination, same, right? That we still had to distinguish it by some tiebreaker, like an ID, right? And so I put ID at the end. Well, a colleague looked at it and said, what the hell do you need an ID for? That has no relevance to whether we should ship it or not, right? So he took it out, right? Now it's not a total order anymore, right? And so we started losing shipments. Like they would not show up. Why? Because, well, this has the same aspects, this has the same aspects, but they're not the same thing because this has ID 1, 2, 3, 4, and this has 5, 6, 7, 8. But that one overwrote that one, and now we only have the first one, right? Whereas if they had read this, no, there needs to be a total order here, or you need to have a way to break ties at the end. That's what that's saying. And so we had to do a really quick bug fix. I said, don't touch my stuff. Right? All right, so there's your lesson for the, don't touch my stuff is the lesson for the week, right?